Imagine gliding at 1,000 kilometers per hour, faster than planes, smoother than silk. Outside, cities vanish into a blur. Inside, it's quiet, almost surreal. This isn't science fiction. It's China's real, near-future maglev train powered by magnets, not engines. Engineers are racing to redefine speed, comfort, and innovation. This is more than transit. It's a bold national statement. China is building the future, and it's doing it faster than anyone else. And if you're fascinated by groundbreaking technology and the future of travel, make sure you subscribe to the channel for more deep dives like this one. To truly grasp what 1,000 kilometers per hour means, we need to reframe our entire understanding of speed. That's about 620 miles in just 1 hour, faster than most commercial aircraft, and nearly 3 times faster than a Formula One car at full throttle. It approaches the threshold of supersonic travel. But this isn't about breaking records for the sake of vanity. This is about China shrinking vast distances, reshaping mobility, and redefining what's possible on Earth. The implications are profound. A trip that might take 5 hours today could be compressed into just 45 minutes, thanks to magnetic levitation technology, commonly known as maglev. Using superconducting magnets to float the train just above its track, maglev eliminates the friction that slows conventional trains. With no contact between train and rail and minimal air drag, acceleration becomes nearly effortless and the ride eerily smooth. Unlike the clunky roar of an engine, these trains move with the calm hum of future technology realized. China's push into maglev is far from casual experimentation. It's a coordinated national effort that combines government backing, state-of-the-art research, and industrial power. Through the China Aerospace Science and Industry Corporation, CASIC, the country is developing prototypes that aim not just to match, but surpass the speeds of Japan's Shanxi or Germany's Transrapid. They aren't refining old designs. They're building what could be the world's first land-based vehicle capable of approaching 1,000 kilometers per hour in real-world conditions. This pursuit is not isolated from China's broader developmental philosophy. When the country decides to build something monumental, it happens fast. Look at its high-speed rail network, which went from a few hundred kilometers to over 40,000 in just over a decade. Now, that same momentum is being directed toward a future where maglev trains integrate seamlessly with existing infrastructure, converting once time-consuming routes into blinking near-there journeys. But perhaps the most futuristic element isn't the train, it's the environment it's designed to run in. This isn't merely maglev on open track. It's maglev within a low-pressure tube system, much like the Hyperloop concept, but with China's difference being this: they're actually building it. By dramatically reducing air resistance inside the tunnel, the system enables these ultra-high speeds to be sustained efficiently and safely. It's the fusion of maglev and vacuum environments that could tip the scales, transforming conceptual brilliance into a transformative force in global transportation. What China is building isn't just a train. It's a technological statement, a reimagining of how we move, work, and live. And if successful, it won't just connect cities. It will compress a continent into a web of high-speed access, shattering the limits of geography and time. This is more than engineering. It's velocity with vision. So, the question naturally arises: why undertake such a monumental and expensive endeavor to develop a train that can travel at these incredible speeds? A train that most ordinary people might not even have the opportunity to ride for several years to come? The answer is multifaceted and extends far beyond the immediate goal of improving domestic transportation. This project is a significant geopolitical chess move, a powerful demonstration of China's rapidly advancing technological prowess and innovative capabilities. It's more than just a train. It's a geopolitical statement, a technological flex that demands the world's attention. While the United States wrestles endlessly with plans for a single high-speed rail in California, and Europe incrementally tweaks systems built decades ago, China is leaping into a realm that feels more science fiction than infrastructure. This 1,000 kilometers per hour maglev project operating in a vacuum tube, represents an audacious challenge to global norms, signaling that China isn't just assembling products, it's now engineering the future. This is a form of soft power like no other. Every meter of vacuum-sealed maglev track laid, every test run that succeeds, is a broadcast to the world: we're not following anymore, we're leading. That narrative carries enormous weight. Technological dominance today means influence tomorrow. And with initiatives like this, China isn't merely catching up, it's setting the pace. If that concept fascinates you, hit the like button so we can dive deeper into these global tech battles. Now, let's explore the science that makes this breathtaking speed possible. At the core of this maglev train are high-temperature superconducting HTS magnets, capable of producing powerful magnetic fields with zero electrical resistance, all cooled with affordable liquid nitrogen. This enables the train to levitate stably above its guideway, even at blistering speeds, eliminating friction and maximizing efficiency. But the levitation alone isn't enough. The game changer is the vacuum tube, an ultra-low pressure tunnel that reduces air resistance to just 1/1000 th of sea level atmosphere. In this near airless environment, drag is minimal, meaning the train can go faster with less energy and less noise. Since there's no wheel-rail contact, wear and tear are drastically reduced, translating into lower maintenance costs and longer system lifespans. Environmental benefits also emerge. Electricity powers this train, and if sourced renewably, emissions per passenger could be dramatically lower than that of commercial flights. Yet, for all its brilliance, the technology remains experimental. Initial tests are set for a 2-kilometer prototype tunnel in Shanxi province. Success there could scale the system across the country, but it's not without hurdles. Engineers must overcome comfort issues for passengers, economic scaling challenges, and the looming global competition. Because in the race to own the future of transportation, whoever builds it first doesn't just move people faster, they move the world's balance of power. Let's not allow ourselves to be completely swept away on the currents of these magnetic dreams without taking a moment to consider the very real and formidable obstacles that lie ahead. Operating a maglev train system at 1,000 kilometers per hour, particularly within a near-vacuum tube, presents a logistical and engineering challenge of epic proportions. Every single aspect of the system, from the grandest structural components to the minutest operational details, becomes a critical variable that must be perfectly managed. Consider the issue of thermal expansion. The materials used for the guideway and the tube will expand and contract with temperature changes, and these tiny movements must be accommodated precisely to maintain the exacting tolerances required for safe levitation at such speeds. Power stability is another immense hurdle. Delivering a consistent and incredibly large supply of electricity to propel the train and maintain the vacuum systems without any interruption is paramount. Emergency evacuation procedures for a train inside a sealed, low-pressure tube present a unique and complex set of challenges that require thoroughly vetted and foolproof solutions. What happens if the train stalls, or if there's a breach in the tube? These are scenarios that engineers must plan for with meticulous care. And then there's the human factor. Beyond just basic motion sickness, the physiological and psychological effects of traveling at such speeds in an enclosed environment, even a comfortable one, need to be comprehensively understood and mitigated. Passenger comfort and safety are non-negotiable. And then, inevitably, we must confront the staggering cost associated with such a pioneering venture. Current estimates suggest that constructing a single kilometer of conventional high-speed rail line can be expensive, but a kilometer of ultra-high-speed maglev line, complete with its vacuum-sealed tunnel, advanced superconducting magnet systems, and sophisticated control infrastructure, could potentially cost anywhere from 60 to 80 million US dollars, or even more. Now, multiply that figure by the hundreds, or potentially thousands, of kilometers required to build a truly transformative national network. Add to that the ongoing operational costs, the immense research and development investment already poured in, and the necessary contingency planning for when things inevitably go wrong at speeds approaching that of sound. The financial commitment is astronomical. Plus, while acknowledging China's remarkable track record of rapid technological deployment, it's also fair to note that there have been instances in the past where new technologies have been rolled out at such a breakneck pace that some initial teething problems or unforeseen consequences have emerged. One might recall discussions around the ghost cities, vast urban developments built ahead of demand, or early challenges with the widespread implementation of certain AI-driven social management technologies. These are not direct parallels, but they serve as reminders of the complexities that can accompany very rapid, large-scale technological pushes. Despite these significant hurdles and legitimate concerns, one undeniable fact remains. When China sets its sights on achieving something that seems almost impossible, when it mobilizes its resources and national will towards a singular technological goal, it has repeatedly demonstrated an extraordinary capacity to simply get it done. While China is forging ahead with its ambitious plans for a 1,000 kilometers per hour maglev train, it's worth taking a brief look at how these efforts compare to high-speed ground transportation projects, or the lack thereof, in other parts of the world. The global landscape presents a varied picture of progress, ambition, and sometimes stagnation. Elon Musk's Hyperloop concept, which proposes passenger pods traveling at near supersonic speeds through depressurized tubes, has generated immense excitement and media attention for years. However, despite some successful small-scale tests and the construction of short test tunnels, primarily in places like Las Vegas by the Boring Company, the Hyperloop largely remains in the realm of conceptual designs, feasibility studies, and ongoing development, with no large-scale commercial systems yet operational or even close to completion. It has faced its own set of significant engineering, safety, and economic viability challenges. Japan, a long-standing leader in high-speed rail technology since the introduction of the Shinkansen bullet train in 1964, continues to push the boundaries with its Chua Shinkansen maglev line. This impressive project is designed for speeds of over 500 kilometers per hour, with test runs already exceeding 600 kilometers per hour. While this is undoubtedly a remarkable feat of engineering and will significantly reduce travel times between Tokyo and Nagoya, its projected maximum operational speed is still substantially slower, roughly 40% less, than the 1,000 kilometers per hour target China is aiming for with its vacuum tube maglev system. The Chua Shinkansen is a testament to meticulous engineering and long-term planning. But China's project represents a leap into an even faster domain. And what about the United States? The situation there presents a stark contrast. While there are ongoing discussions and some localized efforts, the U.S. still lacks a true high-speed rail network comparable to those in Europe or Asia. Amtrak's Acela Express, the fastest train in the U.S., achieves top speeds of around 240 kilometers per hour, 150 miles per hour, but only on limited sections of its route, with average speeds being considerably lower. The California High-Speed Rail project, intended to connect Los Angeles and San Francisco, has been plagued by delays, cost overruns, and political hurdles for years, highlighting the difficulties in implementing such large-scale infrastructure projects in some Western contexts. Therefore, China's pursuit of a 1,000 kilometers per hour maglev train isn't just a matter of domestic technological achievement. It serves as a profound wake-up call to the rest of the world. It's effectively a get-your-act-together memorandum, signaling that if nations or regions are not actively investing in and building the future of transportation and other critical technologies, then another nation will seize the initiative. And once that happens, that leading nation will likely patent the breakthroughs, package the technology, and potentially sell it back to those who lag behind, possibly with significant economic and strategic implications. This race for technological supremacy in transportation has consequences that extend far beyond just how quickly people can travel between cities. Are you finding this exploration of future technology engaging? If so, perhaps you could comment below with your thoughts on which country you think will lead the next wave of transportation innovation. Now, let's shift our focus from the engineering marvels and geopolitical implications to something more personal. The actual human experience of riding this bullet made of pure science. Try to imagine yourself as a passenger settling into your seat on this futuristic maglev train. As it begins to accelerate, you might notice an almost imperceptible sense of weightlessness, a gentle lift as the powerful magnets engage and suspend the entire train car just above the guideway. The journey is characterized by an extraordinary silence, a stark contrast to the clatter and roar of conventional trains or even the hum of an airplane. The world outside the window, if there are windows in the vacuum tube section, or if digital displays simulate the view, might become a mesmerizing, high-speed blur. Or perhaps the designers will opt for an environment where the focus is entirely internal, creating a serene cocoon insulated from the sensation of extreme speed. There would be no bone-jarring turbulence that you sometimes experience on flights. No screeching of metal against metal that can accompany traditional rail travel. Just a smooth, continuous, almost ethereal glide forward. It would be like experiencing flight without wings, a car ride without the vibration of wheels on asphalt, a journey where the traditional sense of traversing great distances is fundamentally altered, compressed into an astonishingly short time frame. What emotions would such an experience evoke in you? Would you feel a profound sense of awe at the human ingenuity on display? Perhaps a flicker of fear or apprehension, given the unprecedented speeds and the novel environment of a vacuum tube? Maybe a touch of disorientation as your senses try to reconcile the lack of traditional motion cues with a rapid change in location? Or is it possible that, like many of us in this hyper-connected age, after the initial novelty wears off, you might simply pull out your smartphone, open TikTok, and scroll through an endless stream of short videos until your brain gently numbs out, the extraordinary journey becoming just another backdrop to digital distraction? It's a curious thought. Regardless of how individual passengers might react, this vision of ultra-fast, smooth, and silent travel is a glimpse into what transportation could feel like much sooner than many of us currently anticipate. It promises to redefine not just the speed of travel, but the very quality and nature of the travel experience itself, potentially making long-distance commutes or inner-city visits as common and effortless as a short trip across town today. So, as we reach the culmination of this exploration, we're left with a pivotal question. Is the advent of the 1,000 kilometers per hour maglev train truly heralding the dawn of a transformative new era in human mobility and technological achievement? Or is it, perhaps, just another incredibly ambitious, high-tech dream that might ultimately collide with the unyielding wall of real-world complexities, economic constraints, and unforeseen challenges? Could it become a stunning but isolated technological marvel? Or will it be the seed of a widespread revolution in how we connect our world? Either way, one thing is abundantly clear. The countdown has irrevocably begun. China is not just theorizing or sketching designs on a drawing board. They're actively building it, pouring massive resources into its development, and pushing the boundaries of engineering. The crucial initial tests are on the horizon, and these will be a significant indicator of the project's trajectory. Once they successfully hit that mind-boggling milestone of 1,000 kilometers per hour in a functional, safe, and potentially scalable manner, there is likely to be no significant slowing down in their pursuit of this technological frontier. The momentum generated by such an achievement would be immense, both domestically and internationally. This entire video, as we've discussed, transcends the realm of just trains and transportation infrastructure. It's fundamentally about something much larger. It's about determining who will lead the technological advancements of the next century, who will set the pace for innovation, and how rapidly they will be able to move towards that future. The implications are vast, touching on economics, global influence, scientific prestige, and the very way societies will be structured and connected in the decades to come. So, the advice is clear. Buckle up, metaphorically speaking, or perhaps more appropriately for this specific technology, prepare to levitate. The future is not just approaching. It's coming at us with astonishing speed. And it's certainly not going to wait patiently at the station for anyone who isn't ready. The landscape of what's possible is changing before our very eyes, and projects like this are at the absolute vanguard of that change.